All right, this is a question from the AP test. It was from the FRQ section with no calculator. So they give us this series, and they say p is a constant that's greater than 0. When p is 1 and x is 3.1, the series converges to s. Use the first two terms of the series to approximate this sum. So if we want to approximate the sum with the first two, let's figure out what those first two are. So if we were to put 1, n equals 1 in for this, we would get negative 1 to the 1 plus 1. X, they told us to use 3.1. So 3.1 minus 3, n is 1. On bottom, then we'd have 5 to the 1 times 1, and then they told us p is also 1 here. All right, so that would be the first term, but they want us to find what the approximate for the first two terms is, so we want to find the next one now. So it'd be plus, and then we'd want to find what it would be if we did the same thing with n equals 2. So now we'd have negative 1 to the 2 plus 1. X, we're still using 3.1 here. N is 2. On bottom here we have 5 squared times 2, and then p they said was 1. So let's try to simplify this and see what this approximation is going to come out to be. So on top, negative 1 squared is just going to be a positive 1. 3.1 minus 3 is going to be 0.1 to the first power. On bottom we got 5, and 1 to the first power is just 1. So it looks like that's just going to give us what we got there. On the other one here now, negative 1 to the third power is going to be negative 1. If we subtract 3.1 minus 3, that's 0.1 squared over 5 squared is 25 times 2 to the first power is 2. Let's keep simplifying because this was no calculator here. All this is just going to be the same as 0.1 over 5. The next part, we do have this negative 1, so I'm going to make this minus instead of plus. And then we got 0.1 squared, which we're going to have well, we'll get to that in a second. So we get 0.1 squared over 25 times 2 is going to be 50. All right, so let's see if we can keep simplifying there into something a little better. 0.1 is the same as 1/10. So we got 1/10 times 1/5 there. Here again, 0.1 is the same as 1/10. So we have 1/10 times another 1/10 times 1 over 50. So this should simplify here then to 1 over 50 minus 10 times 10 is 100. 100 times 50 would be 5,000. So to simplify that, we got to get a common denominator. This would have to get multiplied by 100 over 100 to get a common denominator. So we got 100 over 5,000 minus 1 over 5,000. And so our approximation would be 99 over 5,000. So there, that would answer the first part of that. And so the second part of this question says use alternating series error bound to show this approximation differs from S by less than 1 over 300,000. Okay, so if we are going to show that the approximation differs by less than that, remember if you're going to do alternating series error bound, it should be to that next term. So since we used 2 here, we should show that that's less than the third. All right, so our using alternating series error bound, our S at infinity minus our partial sum, which here is 2, should be less than or equal to the absolute value of that n plus 1 term, which here would be the third term, because it's 2 plus 1, which would give us 3. So here that means we'd have our infinite sum should be less than what we just found, 99 over 5,000. Should be less than or equal to that third term. So what would that third term be here? Well, if you go back to our series, that means we are going to be putting in 3 for our n. So it'd be 3 plus 1 here. Get my absolute value on there. Our x value, they said again, was 3.1 to the third power here, over 5 to the third power times 3, and p they said was 1. So it should be less than that. So what does that simplify to here? Well, that absolute value is going to make our -1 to whatever power just going to be +1 there. Our 3.1 minus 3 is going to give us 0.1 to the third power. On bottom, we have 5 to the third power. So 5 times 5 is 25. Times another 5 would be 125. And then 3 to the first power is just going to be 3. Simplifying that, remember our 0.1, it's the same as 1/10. So that would be 1 over 10 times another 1 over 10 times another 1 over 10 times our 1 over 125 times 3 would be 375. Multiplying that out, 10 times 10 times 10 is 1,000. And so this should be less than or equal to 1,000 times 375, which would be 375,000. And they wanted us to show that this was less than 300,000. And that certainly is, because 375,000 is definitely smaller than 1 over 300,000, because the bigger the denominator, the smaller the number. So that would be enough here to show that our error bound is less than 1 over 300,000.